You will learn what is correlation, what is Pearson's correlation coefficient, how to carry out correlation analysis in SPSS, how to interpret the results. Correlation is a statistical technique that shows how strongly two variables are related to each other or the degree of association between the two. Correlation is used to quantify the association between two continuous variables, for example, between an independent and a dependent variable. Correlation is measured by the Pearson correlation coefficient. The correlation coefficient is measured on a scale that varies from +1 through 0 to -1. Pearson correlation coefficient is denoted by R. It quantifies the direction and strength of the linear association between the two variables. The correlation between two variables can be positive. That is, higher levels of one variable are associated with higher levels of the other. The correlation between two variables can be negative. That is, higher levels of one variable are associated with the lower levels of the other. For example, I take two variables that are job stress and employee satisfaction. The increase in job stress will cause low employee satisfaction, whereas low job stress would result in high employee satisfaction. The correlation between job stress and employee satisfaction is negative. That is, higher levels of job stress are associated with lower levels of employee satisfaction. Let's see the next example. The correlation between innovation and performance is positive. That is, the highest level of innovation is associated with increased firm performance. Innovative companies tend to achieve higher performance. Strength and direction of correlation. The sign of the correlation coefficient indicates the direction of the association. The magnitude of the correlation coefficient indicates the strength of the association. The magnitude of the correlation coefficient indicates the strength of the association. The following guidelines are useful when determining the strength of a positive or negative correlation. 0 indicates no linear relationship. +1 indicates a perfect positive relationship. As one variable increases in its value, the other variable also increases in its value. -1 indicates a perfect negative relationship. As one variable increases in its value, the other variable decreases in its value. Let's look at this table which shows the interpretation of the correlation results. Value 0 means that there is no correlation, association or relationship between two variables. Values between +0 and 0.3 indicate a weak positive relationship. Values between -0 and 0.3 indicate a weak negative relationship. Values between +0.3 and 0.7 indicate a moderate positive relationship. Values between -0.3 and 0.7 indicate a moderate negative relationship. Values between +0.7 and 1.0 indicate a strong positive relationship. Values between -0.7 and 1.0 indicate a strong negative relationship. Now we will look at how to calculate the Pearson correlation coefficient in SPSS and how to interpret the result. For example, this is my hypothesis. BMC is positively associated with OL. In this case, I have two variables BMC and OL. BMC is independent variable and OL is dependent variable. In order to prove this hypothesis and positive association, correlation test will be performed in SPSS. Open SPSS. As you can see, independent variable BMC has 5 items and dependent variable OL has 5 items. Before running correlation test, I will compute the means of BMC and OL. To compute the mean of BMC, which is independent variable, go to Transform, then Compute Variable. In the New Compute Variable window, first enter the name of the new variable to be created in the target variable box. Remember, SPSS does not like spaces in the variable names. A good example is to add the suffix to the variable name to signify that it is a mean. In the numeric expression box, enter the function. Within the brackets of the mean function, enter all of the variables to be averaged, separating each one with a comma. Ensure the variables are entered exactly as they appear in the SPSS data sheet. Finally, click the Continue button to compute the mean variable. After running computing the mean of BMC in SPSS, the new variable, which is mean BMC, is visible in the data sheet. Now I will compute the mean of my dependent variable OL. Repeat the procedure. You can see mean OL is visible in the data sheet. Now I will run correlation test. Click on Analyze, then Correlate, then Bivariate. Move the two variables you want to see whether they are correlated and you want to test over to the variable box on the right. I am moving mean BMC and OL. Independent variable and dependent variable. Make sure Pearson is checked under correlation coefficient. That's it. You are set. Now just click OK. The result will appear in the SPSS output viewer. The result will display the correlation in a table. You can see the results as A. Correlation of BMC with itself. R is equal to 1. And the number of observations for BMC N is equal to 334. B. Correlation of BMC and OL. R is equal to 0.883 based on N is equal to 334 observations. C. Correlation of BMC and OL. R is equal to 0.883 based on N is equal to 334 observations. D. Correlation of OL with itself. R is equal to 1 and the number of observations for OL N is equal to 334. The important cells we want to look at are either B or C. Cells B and C are identical because they include information about the same pair of variables. Cells B and C contain the correlation coefficient for the correlation between BMC and OL. Calculation was based on the correlations in the main diagonal. Cells A and D are all equal to 1. This is because a variable is always perfectly correlated with itself. SPSS correlation table cells always contain at least 3 pieces of information. Number 1. The size of the correlation. SPSS will mark a 0.05 significance level with 1 asterisk, a 0.01 significance level with 2 asterisk. Number 2. Level of significance for the correlation. The level of significance is 0.000, which means that the test is significant. Number 3. The number of observations. Decision and conclusions. Based on the results, we can state the following. Number 1. BMC and OL have a statistically significant linear relationship. Number 2. The direction of the relationship is positive, that is, BMC and OL are positively correlated, meaning that these variables tend to increase together. That is, greater BMC is associated with greater OL. From the table, it is observed that the correlation coefficient R is 0.883, which is interpreted as a large coefficient. The p-value is less than 0.001, indicating a highly significant result. I hope you have understood about correlation and how to run correlation analysis in SPSS. Stay tuned for more videos.